Hey everyone, I had a question that I wanted to do a short video on. Rather than just kind of write something up, I thought it might be easier to just go ahead and do a video on it. So the question is converting a base 10 or a decimal number to a base 16 or hexadecimal. And let me show you what we have here. So this is it right here. So it's 5344 base 10 to base 16. So kind of the official way of doing it is first off to figure out what your first several base 16 slots are. Okay. So we always start with ones, which if you want to, you can think of as 16 to the 0 power, but I think of it as ones. And the way we go from every slot to kind of the next bigger slot is we multiply by 16s. So 1 times 16 is 16. Next bigger one, 16 times 216 is 256. So that's going to be that group size. Next one's going to be 256 times 16, which is 4,096s. Okay, so every time I'm multiplying by 16. Okay, what's the next one? 4,096 times 16. I don't know, but I know, well, hang on, I have a calculator, so yes, I do know. I know I'm not going to need it. I'll tell you why here in a second. So this is 65,536. 65,536. Okay. The reason I know I'm not going to need it is because that is way bigger than 5,344. There's none of that group size that I can take out of there. So kind of the way you do it is you go till you find the slot that you are not going to need. And I'm going to start with this one right here. Okay. So when I say I'm going to start with this one, what I'm going to do is I'm going to see how many groups of 4,096 I can take out of 5344. So I'm doing division. So I have 5, 3, 4, 4. Okay. I divide by 4,096. Okay. I get 1, and I have a remainder. So let me figure out the remainder. So 5344 divided by 4,096 is 1. Okay. I have a video on how I find these remainders that's in the content section. So it's 1.30 and some stuff. So I subtract off the nice integer part, which is the 1. I get my hands on the decimal, and I multiply back what I was just dividing by, which is 4,096. So my remainder is 1248. If you have a way you like of finding remainders, use it. Okay. So what happens is that 1 right there goes there. So it says I can take out one group of 4,096. Now we still have that 1248 that I have to kind of package up in these base 16 placeholders. So now what I'm going to do is I'm going to take 1248 and I'm going to divide by the next smaller placeholder. So now I'm down to 256s. So I'm going to got my calculator, do 1248 divided by 256. So I get 4 and stuff. That stuff is my remainder. Okay. So it's 4.875. So I subtract off the 4 and I multiply back by what I just divided by to get my remainder. So I get a remainder of 224. Okay. That 4 goes up there. Now I still have 224 that I have to, I'm going to just kind of do this so I don't go too far down. So I still have 224 that I have to package up in the base 16 world. So what I'm going to do is I'm going to take that 224 and I'm going to divide by the next package size smaller. So now I'm down to the 16s. So I do 224 divided by 16. And I get 14 with a remainder of 0. Okay. That 0 is telling me I'm not going to have any left over. Okay, so keep that in mind for a second. The 14, I want to kind of put there. Oops, sorry. I want it to bring from there to there. Okay. But If I write a 1-4 up there, that's going to throw everything off by a slot. It's going to move this front one here up into the 65,536 slot and so on, okay? So when we're doing this, every time we do a division, our quotient has to be written as a single digit numeral. So the way we fix that in the base 16 world, because I have a 14, which is normally a 2-digit number to me, we have to come up with a way of representing that as a 1-digit thing. And this is why we use these capital letters to represent the first several what would normally be 2-digit numbers. Okay. The next one would be a 16, but that would be represented as 1-0 in the base 16 world. So when you're doing these calculations, every division should give you a single digit. So when I want to write 14 up here, I say, oh, well, it's a 2-digit number and I can't have that. But how do I write to what I think of as 14? How do I write that in the base 16 world? So it's E, okay? So that thing is going to go there. Okay. So remember, that's how many groups of 16 I can take out of that 224. If I had a remainder, what I would do then is I would divide it by the next smaller group size. Okay. I guess I could still kind of do it this way, but I would normally just stop. But my remainder here is 0. So the next calculation I could do is I would do 0 divided by 1, which is 0. So that tells me in this case that far right digit is actually going to be a 0. Okay. What that actually tells me is that the number 5,344 is actually divisible by 16. When I divide by 16, it has nothing left over. Like a base 10 number is divisible by 10 if and only if its last digit is 0. The same is true for other bases. Okay, so I wanted to go through this example. It actually has 2 good things in it for teaching. That is the fact that you have a 2-digit number that you have to represent as a 1-digit number. So remember, every time you do a division, you need to end up, you're cranking out a digit is what you're doing. So each one has to be a 1-digit or 1-symbol item. So that's why we use these things here, okay? And in this case, once I did this division where I had 0 left, that's telling me that the next and last placeholder is going to be a 0, because there are none left that I have to package up in base 16 world. So at any point in this, if you get a 0 remainder, all your following digits are going to be 0. Okay. So to make a long story short, what we just did is we took 5344 base 10, and we wrote that as, I'm looking up here at the digits that I just cranked out, 14E0 in the base 16 world. Okay. That's kind of the official way of doing it, but I don't know when to leave well enough alone, so I'm going to show you a different way of doing it. If you like this, you can ignore what I'm about to do. What I'm about to do is actually a little bit quicker, and I will show you why. Okay, so completely new way. So let's go back here, start with a new screen, new whiteboard. So I want to take the same exact problem, which was what, 5,000? I'm going to have to go back here and look because I can't remember anything. 5344. I don't need that. Okay, so same problem. So if you like the way I just did it, like I said, that's kind of the official way. That will work. That's fine and dandy. I'm going to show you this way because it's a little quicker. Okay, so let's call this method 2. Okay, so what I'm going to do, unlike last time with the official method where I actually cranked out the first several placeholder sizes for base 16, I'm just going to start dividing by 16. So watch. I'm going to take my 53 0.44, and I'm going to divide by 16. I'm going to write it a little weird because it kind of matches up nicer here. Okay, I'm doing division, but I'm writing it kind of weird. So I'm going to take 5344. Okay. Notice that last time I actually cranked out 5344 divided by 4096 first, because I determined that that was going to be the biggest group size that I could take out of this thing. This fancy algorithm actually takes care of that. I don't have to calculate these placeholder sizes at all. So I'm going to take 5344, divide by 16. So what I get is 334 even, which means I don't have any remainder whatsoever. Okay. Now what I'm going to do is I'm going to put 16 into the 334. So I'm going to take 334 and divide by 16. So here I get 20. Okay. Let me figure out my remainder here. It's a remainder of 14. And I'm going to keep playing this game. So now what I'm doing is I'm collecting my remainders on the right-hand side. Once I write those down, I can kind of forget about them for another minute or so. Now I'm going to keep putting 16 into what technically I guess is my quotient. Okay. So 16 goes into 20 once with a remainder of 4. And 16 goes into 1 0 times, but I still have that remainder of 1. Okay. So using this kind of fancy algorithm, I can tell which step is my last by the fact that I'm taking something smaller than 16 and dividing it by 16, and I get 0. And that entire thing I was dividing by 16 is my remainder. Okay. Now what I want to do is I want to read this from the bottom up. 1, 4. This should sound familiar if you followed what I did the first time around. Those are my first two digits. 14 and 0. Those are the digits I just cranked out. But again, see this discussion from a couple of minutes ago. This right here, this 14, I need it to be a single digit thing. So that is, let's see, B, C, D. That's an E. You'd think I'd have these memorized by now. Okay. So now read these from the bottom up. 1, 4, E, 0. Okay. Which is what we got the other way. Okay. So whichever way you like, you are welcome to use. They both work. You know, the other one's kind of the official way. It shows you exactly what's going on under the hood. You know, you're taking out the largest group size possible, then you're moving on to the next one and you're working on that remainder doing that. The advantage to this method right here is that you don't have to worry about the placeholder sizes. But if you understand what's going on here, that's not a really big deal. You can knock those out quickly. But this thing kind of does it for you. Okay, thanks for watching.